In part A of this problem, we're trying to find the speed of the rocket after the 2 seconds of firing the engine. So initially it starts at rest and it accelerates, it tells us, at 30 meters per second upwards. So we're overcoming gravity, but we already know the acceleration. We're trying to find the speed. We know the initial velocity is 0, we know the acceleration is 30, and we know that it goes for 2 seconds, so this is a kinematics problem. So we look at our kinematics equations, and we see that we have to use the equation without displacement in it. So we go ahead and plug in our numbers, and we see that the speed is 60 meters per second. For part B of this problem, trying to find the maximum height the rocket will reach, we are trying to solve for now the displacement. Now this problem, in this particular situation, there's two types of motion going on. In any situation, there's always two options. Either the object's moving at a constant speed or a constant acceleration. Now in this case, technically the rocket is accelerating in both cases, but initially it accelerates at 30 meters per second squared for 2 seconds, and then after the engine shuts off, the acceleration is negative 9.8 meters per second. Now it's basically in free fall, even though it's still going up because it had that velocity. Now it is technically in free fall. So we look at the first 2 seconds and we solve for the displacement, and we see that it goes up 60 meters. And then after 60 meters, engine shuts off. Now there's no more force, there's no more thrust accelerating it upwards. So now the only force acting on this rocket is gravity. So now we have to use our kinematics again with different variables. We start off at 60 meters per second at that point. We know that the final velocity and maximum height is 0, and of course we know gravity is negative 9.8. So we solve for that, see that the displacement, or the maximum height from that point, is 183 meters, and we have to add them together because, again, we're trying to find the maximum height above the ground. Now for part C, trying to find the magnitude of the resistive force from the parachute as the rocket descends, we know that it is moving at a constant speed. Now remember, constant speed means that the net force is 0. So don't think net force means it's not a net force of 0 means it's not moving. It means it's not accelerating. Clearly it's still moving though, but the net force is 0. We know that there's force of gravity acting down. As always, any object really, there's always a force of gravity, and there's air resistance acting up. The parachute adds this force. So the two have to equal each other, again, because net force is 0. So basically the air resistance is equal to the gravitational force, 14.7 newtons.